Welcome back to our video series in math. Today's topic is on right triangle trigonometry. And we will be looking at solving right triangles and using the right triangle trigonometry to solve some applied problems. Here's one question, and all of the questions will be the same. There'll be some worded kind of things, and what you need to do is to draw some kind of triangle out of them. Let's maybe get a triangle started. Here's a triangle right about like that. Beautiful. So our first question deals with something called angles of depression and angles of elevation. This is one that typically has caused lots of problems for students. The question says the angle of depression from a hot air balloon. Okay, so here's our hot air balloon right here, and we'll put it right there. Beautiful. The angle of depression from this hot air balloon to a fire. Let's draw a roaring fire right down there. Is 20 degrees. If the balloon's 2.3 kilometers from the fire as a crow flies, and I guess we could make that line or this line. I had originally intended it to be this one. So from a point directly below the balloon on the ground, as a crow flies to the fire, would be 2.3 kilometers. So the question is, how high is the balloon? Let's call that h. So the only thing I have to worry about now is this thing of angle of depression to a fire's 20 degrees. Angle of depression means if I'm standing here in this balloon and I'm looking straight out, that's sort of straight, the angle of depression from that line straight out down to where I see the fire, that's 20 degrees. A lot of people mistakenly put this angle here as 20 degrees, but it's not 20. So the angle of depression is if I'm looking straight and then I come down till I finally see the fire, that angle is 20 degrees. Now, since these are parallel lines, this is a transversal. You might remember those words from before, but it means that this angle is 20. If this angle is 20, it means that this angle here is also 20 degrees. So I have a triangle where I know two pieces of information. I know an angle and I know a side. So I can use my trig ratios to solve for whatever other side or angle that I need. In this case, I'm looking for the height. From this angle, I mark my angle. From this angle, this would be the opposite side. And this side here would be the adjacent side. So if I'm looking for the opposite, I know the adjacent. That would be the tangent ratio. So tan of any angle is equal to the opposite side over the adjacent side. So tangent of 20 degrees is equal to the opposite side. I don't know, but we've called it h. Over the adjacent side is 2.3 kilometers. Multiplying both sides by 2.3 kilometers isolates my h, and to solve I would go 2.3 times the tan of 20 degrees. We'll just do that. So 2.3 times the tan at 20 degrees gives me about 0.84. So the height is approximately 0.84 kilometers up. So that's angle of elevation, angle of depression. Angle of elevation, I should have given you that too. This is the angle of depression, looking straight out, angle to come down. Angle of elevation could be from the fire. So from the fire, looking straight out, and then looking up to see the balloon, that angle is the angle of elevation. Here's another good question where I need to use two ratios, and I have a common unknown. A weather balloon, there it is right there, is directly west of two observing towers that are 15 miles apart. So is 15 miles apart. The angles of elevation of the balloon from the two stations are 18 and 75. Okay, so let's draw some lines here. Here's a balloon. Let's go straight down. And let's go from the balloon, and let's go to the first tower. And let's go from the balloon, to the second tower. So they say the angle of elevation is 18 and 75. So either this is 18 and this is 75 or vice versa. This one looks like a greater angle, so I'm calling this one 75. This is probably way closer in, but and this angle is 18 degrees. I'm not too bad with that one. So angles of elevation 18 and 75, and they want to know how high this balloon is. Let's call that one h again for height. So I guess I have a problem here in that I don't have two pieces of information about any of these triangles. If I look at, say, the smaller triangle here, so this is 75, this is h. See, I only have this piece of information, but I don't have the length of a side. Of the other longer triangle, again, I have this is 18 degrees. This is what I'm looking for, but I only have a partial side. Like that's 15 there. But it's only from here to there, not the whole way. So I don't have whole information about either of these triangles. But I do have a common side. If I have a common side, I can use each of these, set up a ratio. Because I have a common side, I can solve for that side. And this is how we do it. We call one of these sides down here a variable. Let's call it x. So this from here to here is x. We don't know that distance. Also, this distance from here to here would also be x. So this entire distance would be x plus 15. Now let's set up the ratios. So the ratio for this triangle here would be opposite over adjacent, that's tangent. So tan of an angle is equal to opposite over adjacent. So the tan of 75 degrees is equal to the height of the triangle over this distance we call x. Over on this one, to set up the ratio, again it's tangent ratio. So tan theta is equal to opposite over adjacent. Tan of 18 degrees is equal to the height over this whole distance, which would be x plus 15. Now, since the h is equal to h, I can solve these two. So I'm going to solve this triangle for h by multiplying both sides by x. And I'll solve this one for h by multiplying both sides by x plus 15. So, since the heights are the same, and I'll just write that, since the height must be equal to the height, it also follows that x times the tangent of 75 must equal x plus 15 times the tangent of 18. And that's the trick that you do with this question. To finish this off, you would simply figure out what the tan of 75 is, times it by x. Figure out the tan of 18, multiply it by both of these. Eventually you'll get down to x is equal to some number. That'll give you that distance from here to here. Knowing that distance, I can plug into either this formula or this formula for x and solve for h, which is what we were looking for. But the key part of this question was to recognize that there was a common height. If there's a common side in those two triangles, I can use, this is basically system of equations solving by substitution. I can use that to solve for the variable. Key thing, common side. The last part in this section has to do with bearings, and I won't do any questions with bearings, but just to give you an idea of how to read a bearing. So say if they had a question that said, say north 36 degrees east. So if they had that, then to read this bearing, I would say I would think of north, and then I'd say 30 degrees east of north. So here's east, so 36 degrees east of north. So that would be my bearing there. So if they say the bearing is north 36 degrees east, then it would be north 36 degrees off of north, headed toward the east. So say if I had south 112 112, maybe not 112. How about south 80? Yeah, south 80 degrees west. So this would be, I'm heading south, but I go 80 degrees off of south towards the west. That would be that bearing. Okay, so the key concepts we've talked about today have just been some right triangle trigonometry. The idea of angle of elevation or angle of depression, we looked at that. And we also looked quickly at a question where I had a common side and I could use system of equations to solve that.